Hi dear students, welcome back to online classes. I am your Virupaksha BP. In last video we have discussed about units and measurements. Today we are going to discuss about uncertainty in measurements. Every measurement has some degree of error or uncertainty. Uncertainty means error. Okay, every measurement has some degree of error or uncertainty. The error which depends on two factors. The one is skill and accuracy of worker, and the second one is limitations of measuring instruments. The error which depends on two factors. The error which depends on two factors. The first one is skill and accuracy of worker. Yes, if worker did not follow proper method, then we will get errors in measurements. The second one, limitations in measuring instruments. Yes, if measuring instruments are not proper, then also we get error in measurements. This is uncertainty in measurement. Uncertainty means what? Error in measurement. Every measurement has some degree of error or uncertainty. This error depends on two factors. One is the skill and accuracy of worker. The second one is limitations in measure of instruments. If worker did not follow proper skill or proper method, then also we get errors in measurements. The second one, if the instruments are not in proper, then also we get error. The next one, scientific notation. Scientific notation. This is very important for 1 mark. In exam, they will ask like this. He will give one number and he will ask you to convert into scientific notation. Then what is scientific notation? Why they have introduced scientific notation? We know that in chemistry we are going to study about atoms and molecules. Atoms and molecules are very, very small in size. The mass of atoms and molecules are very small in size, and the number of atoms and molecules are very large in number. The calculation of very large number and very small number is difficult. To avoid difficulties, they have introduced scientific notation in chemistry. Then what is the scientific notation? Scientific notation means capital N into 10 power small n. This small n, it may be positive or negative. Then where n is any number between 1 to 10, any number between 1 to 10. The small n, it indicates exponent value. exponent value. Exponent value. These exponent values either be positive or negative. Okay. Any number we can express in scientific notation. Either it may be very small number, either it may be very large number. We can express in scientific notation. Okay. When we are going to write in scientific notation form, we have to shift the decimal point in left side or right side direction. If decimal point is shifted in right side, according to you, this is the right side, this is left side, this is left side, right? According to you, this is right side direction, this is left side direction. If decimal point is shifted to right side, RHS, right hand side, then we have to mention negative sign. We have to mention negative sign for exponent values. If this decimal point is shifted towards left side, means left hand side, then we have to put a positive sign for exponent values. This is very important. Okay. When very large numbers or very small numbers are writing in scientific notation, we have to remember this one. When the decimal point is shifting right side, you put negative sign for exponent values. When decimal point is moving left side, then you put positive sign for exponent values. Now let us check some examples. The first example, 0.0000256. In exam, he will give very small number like this number. He will give one number and he will ask you to write in scientific notation. Now the number is 0.0000256. Now we have to write in scientific notation. How do you write in scientific notation? The scientific notation is n into 10 power small n. This small n is exponent value. Now to write in scientific notation, we have to shift the decimal point either left side or right side. Now we will check the first example. Here the decimal point is here. To write in this form, the n value should be between 1 to 10. Here before decimal point the value is 0. Then it is not scientific notation. So we have to shift this decimal point from year to year. From year to year. When this decimal point is shifted, then this number is 2.56 into 10 power. Now tell me, the decimal point is shifted towards right or left side? It is shifted towards the right side. Then which sign we have to mention there? Negative sign. We have to mention negative sign. Then what is exponent value? Exponent value means the number of places. The decimal point is shifted or crossed. Now tell me, the decimal point is here. Next, this decimal point is shifted from year to year. Okay, how many numbers this decimal point is crossed? 1, 2, 3, 4, 5. The exponent value is 5. This is scientific notation for this number. Okay, the second example, 3567.8.26. Now you write in scientific notation. Write this number in scientific notation. See here, this is very large number. See here, 35,678.26. In scientific notation, the n number should be between 1 to 10. That's why here we have to shift this decimal point towards the left side. You have to shift this decimal point towards the left side. Means you have to shift to here. When you shift it to here, then it becomes 3.567826 into 10 power. Here, now in this case, the decimal point is shifted towards left side. If decimal point is shifted towards left side, then what is the sign? Positive sign. Okay, now what is the exponent value? Means how many digits the decimal point is crossed. Now let us check. 1, 2, 3, 4. Okay, the exponent value is 4. In this way, we have to convert the very large number or very small number into scientific notation. Next, the third example. 1, 2, 3, 4.0216. Convert or write this number in scientific notation. Now tell me, which side we have to move this decimal point? We have to move left side or right side? To write in scientific notation, which side we have to move the decimal point? Left side or right side? See, in scientific notation, n. What is n? N, the number, any number between 1 to 10. The number should be 1 to 10. So we have to shift this decimal point from here to here. Okay, means the decimal point is shifting left side. Then write 1.234016 into 10 power. Which sign we have to mention here? Tell me. Now here, in this case, the decimal point is shifted towards left side. So which sign? Positive sign. Okay, then what is exponent value? Now check how many digits this decimal point is crossed. 1, 2, 3. The exponent value is 3. Okay, next, the fourth example. 0.0078006. Now you convert in scientific notation. Write this number in scientific form. Now tell me, which side we have to shift the decimal point? To right side or to left side? The n number should be between 1 to 10. So we have to shift towards right side. This decimal point is shifted towards the right side. Then you will get 7.806 into 10 power. Positive sign or negative sign? See here the decimal point is shifting towards what? RHS, means right side. Right side means what? Negative sign. Then what is exponent value? Exponent value means number of digits the decimal point is crossed. 1, 2, 3. This is scientific notation for this number. And the last example, 1.26. Now write in scientific notation. Now you write this number in scientific notation. Which side we had to shift the decimal point? Left side or right side? We don't shift to right side or left side. Why? Because it is already in scientific notation. It is already in scientific notation. See here, before decimal point, the number is in between 1 to 2. So it is already in scientific notation. So we cannot shift the decimal point either towards right side or left side. Okay. Scientific notation in multiplications and divisions. Now let us check one example. 1.2 into 10 power 2 into 1.2 into 10 power 2. Multiple these two numbers. How do you multiply these two numbers? In multiplication, the exponent values are added. We have to add exponent values. Let's see how we can multiply these two numbers. First you write, in this number there is 1.2 into here 1.2. Okay, next here 10 power 2, here 10 power 2, means we have to add exponential values, means we have to add powers. 2 plus 2. Now you multiply 1.2 into 1.2. What? 2 to the 4. Okay, see here I will multiply here 12 into 12. 2 to the 4, 2 1 ja 2 into 1 to the 2, 1 and 1, 144, means 1.44 into 10 power 4. This is scientific notation. In the multiplication, we have to add the exponential values. Next, the another example. 1.2 into 10 power 6 into 1.8 into 10 power minus 4. 10 power minus 4. Now you multiply these two numbers and write in scientific notation, and write the final answer in scientific notation. First you write in simple form 1.2 into here what is 1.8. okay, we know that the power should be added. 6 plus here what is exponential value? Minus 4. okay, now multiply these two values. 12 into 18, 8 to ja 16, 8 1 ja 8 plus 1 9 into 2 1 ja 2, 1 1 ja 1, 6 and 11, 216, means 2.16 into 10 power what? 6 minus 4 means what? 2, it plus 2. This is the final answer in scientific notation. In multiplication, the exponential value should added. Okay, next one more example for division. 7.2 into 10 power minus 3 divide by 2.4 into 10 power minus 6. Now divide these two numbers and write the final answer in scientific notation. Okay, this is in denominator. In denominator there is a 10 power minus 6. Now you shift this to numerator. 7.2 divided by 2.4 into 10 power minus 3 into 10 power plus 6. The minus 6, when it goes into numerator, it becomes positive. Next, 7.2 divided by 2.4 is equal to 3. 3 into 10 power 6 minus 3, 3. This is the scientific notation in multiplications and divisions. The next one is addition and subtraction. In addition and subtraction, we had to write the final answer in scientific notation. How to write the final answer in scientific notation? Now let us check one example. 7.26 into 10 power 5. The another number is 6.25 into 10 power 4. Now these two numbers are in scientific notation. These two numbers are in scientific notation. Now add these two numbers. Directly we cannot add these two numbers. 7.26 into 10 power 5, 6.25 into 10 power 4. We cannot add these two numbers directly. Why? Because the exponent values are in different. It is 5, it is 4. Before adding the numbers, we should change or we should arrange the numbers in such a way. In both numbers, the exponent value should be same. Okay, to get same value, to get same exponent value, I am going to shift the decimal point. We can shift the decimal point in any number. You can shift in first number or in second number. Okay, now I am going to shift the decimal point in second number. Now I am going to shift this decimal point from year to year. Then what happens? This number will converted into 0.625 into 10 power 4 into 10 power 1. Why 10 power 1? Because here the decimal point is just shifting towards left side. If it is shifted towards the left side, then we have to write which sign? Positive sign. And this decimal point is crossed one digit. That's why 1. Now you write this one, 6.25 into 10 power. What? If the multiple is there, if the multiplication is there, then we have to add two exponential value. Then the exponential value is 5. Now in both numbers, the exponent values are same. Now we can add the numbers. Add these two numbers. 7.26 into 10 power 5 plus 0.625 into 10 power 5. Here in both numbers there is a 10 power 5, 10 power 5. So you take common 10 power 5, and next remaining number 7.26 plus 0.625. Add these two numbers. You will get final answer. Add these two numbers, 7.26 and 0.625. Right? 5, 8, 8 and 7. 7.885 into 10 power 5. This is the final answer in scientific notation. Okay. In addition and subtraction, we should not add or subtract the numbers if exponent values are different. If exponent values are same in both numbers, then you can add or subtract the numbers. The second example, 4.8 into 10 power minus 3. Okay. Next, 5.1 into 10 power minus 4. 4.8 into 10 power minus 3, and the second number is 5.1 into 10 power minus 4. Subtract these two numbers. Before addition or subtraction, first you have to check the exponential values, the exponent values. Here the exponent values are different. So first we have to make them same. To make it same, just I am shifting this decimal point from year to year. If I shift from year to year, what happens? It converted 5.1 is equal to 0.51 into 10 power minus 4 into 10 power plus 1. Correct? Why? Because this decimal point is shifting towards the left. That's why positive. This decimal point is crossing one digit. That's why 1. Next 0.51 into 10 power minus 4 here plus 1. So minus 3. Now the exponent values are same. Now you can easily subtract the values. 4.8 into 10 power minus 3 minus 0.51 into 10 power minus 3. Now subtract these values. In both numbers, the 10 power minus 3, 10 power minus 3. So you take common. 10 power minus 3 is common. Now you subtract 4.8 minus 0.51. 4.80 minus 0.51. You take here 1. 10 minus 1 means what? 9. Here 7. 7 minus 5 means what? 2. 4.29. 4.29. Okay, this is the addition and subtraction. The next concept is scientific significant figures. Okay, before going to significant figures, let us know what is precision and what is accuracy. The first one is precision. And the second one is accuracy. Just by knowing the definitions or just by reading the definition, we cannot understand the exact meaning of precision and accuracy. Now let us see what is accuracy and what is precision. Precision means if the values of different measurements, if the values of different measurements are close to each other, then the measurement is said to be precision. When the measurement is precision, if the values of different measurements are close to each other, then the measurement is said to be precision. Then when the measurement is said to be accuracy, now let us see the definition of accuracy. If the average value of different measurements if the average value of different measurement is very close to true value, then the measurement is said to be accuracy. When the measurement is said to be precision, if the values of different measurements are close to each other, then the measurement is said to be precision. If the average value of different measurement is very close to true value, then the measurement is said to be accuracy. I have already said, just by reading the definition, we cannot understand exact meaning of the precision and accuracy. Okay, to know exact meaning of precision and accuracy, now let us see one example. Okay, see here, mass of substance is, the mass of substance is 2 gram. Means it is true value. The true value of substance, the mass of the true value, this is 2 gram is true value. Mass of substance is 2 gram. This is true value. True value. Okay. Next. In the class, there are 3 students are there. Students A, B, C. These 3 students have done two experiments. Experiment 1, experiment 2. Okay. Next, this is average value. Average value. This is average value. 3 students have done two experiments. Student A student has done 2 experiments. Means he calculated the mass of substance in 2 trials. In first trial, A student got 1.95 grams. The mass of substance is 1.95 grams. In second experiment, same student got 1.93 grams. 1.93 grams. Then what is the average value? Average value means what? Add these 2 numbers and divide by 2. 1.95 and 1.93. Add these 2 numbers and divide by 2. You will get 1.94 gram. 1.94 gram. Similarly, B student has also done 2 experiments. In first experiment, he got 2.05 gram. The mass of substance is 2.05 gram. Okay. In second experiment, he got 1.94 grams. He got 1.94 grams. The average value 2.05, 1.94. The average value you will get nearly 1.99 grams. Similarly, C student. In first experiment, C student got 2 grams. Okay. In second experiment, also he got 2 grams. The average value is 2 grams. Now tell me, here there are 3 measurements, means there are 3 students are there. Which student measurements are accuracy and precision? Now let us check. What is precision? If the values of different measurements are close to each other, then the measurement is said to be precision. Now check it. Student A, he got 2 values. One is 1.95, the another one is 1.93. These 2 values are closer. There is a lot of difference between these 2 numbers. These 2 numbers are very close. These 2 numbers are very close to each other. See a definition, the values of different measurements. Values of different measurements are close to each other. Then this measurement is said to be what? Precision. So it is precision. This is precision. Precision. Now check whether it is accuracy or not, and whether this measurement is accuracy or not. What is the meaning of accuracy? If the average value of different measurement is very close to true value, then the measurement is said to be accuracy. Now what is average value? 1.94 gram. What is true value? 2 gram. This is not close to true value, so it is not accuracy. This measurement is not accuracy. Not accuracy. Accuracy. Okay. Next, second one, B. Let us check B. These 2 values are close to each other or different? These 2 values are different. They are not close to each other. They are not close. They are not close. That means no precision. No precision. No precision. And what about accuracy? The average value is 1.99 gram. This is the average value is very close to the true value. It is very close to the true value. That is why this measurement is accuracy. Accuracy. Okay. Next, third measurement. Here the values of different experiment, the values of different measurements are very close to each other. That's why this measurement is said to be precision. This is said to be precision. And what about accuracy? The average value is close to true value or same to true value. That's why this measurement is also accuracy. The measurement is said to be accuracy. Okay, this is the difference between precision and accuracy. Precision means what? If the values of different measurements are close to each other, then the measurement is said to be precision. Here these two values, two different values are very close to each other. That's why this measurement is precision. And what about accuracy? The average value of different measurement is very close to true value. Then the measurement is said to be accuracy. Here the average value is not close to the true value. That's why this measurement is not accuracy. Okay. In next class we will continue. Thank you.